Okay, YouTube, this is a brief warm-up video, just a problem of the day before we start our properties of logarithms unit. So really quickly, what we're going to do here is graph the function f of x equals log base 3 of x minus 3 plus 1. And basically the thing that I want to reiterate here, and I should really be calling this some g of x and not f of x, because I'll tell you, g of x is typically representing the transformation of a function, but we say the parent function here without any transformations, without this 3, without this 1, without I guess an alteration to a value out in front, which is not very altered because it's 1, but we'd say we'd have y equals log base 3 of x. And so if we were to sketch this, a few things we want to remember about all logarithmic functions. They are inverses of exponential functions, and so that means that in an untransformed state, they're going to have a natural vertical asymptote on the y-axis here at x equals 0. So x equals 0. Also this, the point 1, 0 must be on this graph here. Now, if we're going to review y, I think it's not a bad idea to at least plot a couple of points on this table here. But we could see that if we were to plug in 1 into this function here, we would get really f of 1, which would be log base 3 of 1. And what we're really asking is, what could I take 3 to the power of to turn it into 1? Well, the only thing I could think of is 0. So we get 1, 0 on this graph. And then also, if I'm going to plug in any other x value, you know I'm going to plug in 3. And the reason why is because we have a log base 3. Recall that whenever you have, say, log base, say in this case, 3 of 3, or anything of itself here, you're going to get 1 because 3 to the first power turns into itself. So we have 3, 1. And so on this graph, I would go right 3, up 1, would be this point right here. And we'd say that this is our parent function here that grows more and more slowly. It's getting more and more level. It's always increasing, but its slope is decreasing here. So we'd say, looking at this function, how would this one then, g of x, be different from f of x, its parent function? Well, I noticed that because this is our h value here and this is our k value, we can see that this is going to shift right 3 units and up 1 unit. So just really quickly, what we're going to do is we're going to grab every point on this graph and move them right 3 up 1. So we'll start with this 3, 1. If we go right 3, we'll be at an x value of 6 and then a y value of 2. So we'd say that this would be 6 comma 2. Right 3 up 1 from 1, 0 would be at a x value of 4 and then a y value of 1. So we would say that this would be the point 4 comma 1. And then last but not least, we would have to move the asymptote 3 to the right as well. So the asymptote of our transformed graph, or this blue graph right here, would have to be at x equals 3. And we would say that our graph basically would look similar to its parent, which would be a graph that is growing more and more slowly, very, very, very slowly. So really quickly, let's indicate the domain and range of this blue graph. One thing that's really important with logarithmic functions is that since they're inverses of exponential functions, their ranges are all real numbers, and we could observe this from the graph here. But the domain is going to be all x values to the right of that asymptote. And because we witness it occurring at 3, we'll just say 3 to infinity, not including 3. Cheers.